In this video, I'm going to show you how to use the sum and difference formulae for cosine. So we've got the sum formula, cosine of x plus y is equal to cosine x times cosine y, then minus sine of x times sine of y. And then likewise we have a difference formula, cosine of x minus y is equal to cosine of x times cosine of y plus sine of x times sine of y. So why don't we do some examples of these formulae in action. First of all, we'll use the sum formula to compute the value of cosine of 75 degrees. And 75 degrees, unfortunately, that is not a special value where we just know what cosine is, but we can write it in terms of two special values. We can write 75 degrees as just 45 degrees plus 30 degrees. These are two special angles for which we know the values of sine and cosine, and they sum to 75 degrees, so we can just plug them in our formula here and evaluate. So let's go ahead and do that. Cosine of 45 degrees plus 30 degrees. Plug that into our formula and we get that's equal to cosine of 45 degrees, the first term, and then times cosine of the second term, 30 degrees, and then minus sine of first term, x is 45 degrees, and then times sine of the second term, which is 30 degrees. And now we'll just evaluate cosine of 45 degrees, that is just root 2 over 2, and cosine of 30 degrees, that is just root 3 over 2, and then minus sine of 45 degrees, that is just root 2 over 2, and sine of 30 degrees is just 1/2. So let's go ahead and multiply this. Root 2 times root 3 is root 6, 2 times 2 is 4, then minus root 2 times 1 is root 2, and then 2 times 2 is 4. So altogether, putting that together, that's just root 6 minus root 2 over 4. And there we go, we're done. Now let's do a similar thing using the difference formula to compute the value of cosine of 15 degrees. Now 15 degrees, that also is not a special angle, unfortunately, but we can write it as the difference of two special angles. It's just the difference of 45 degrees and 30 degrees. So we'll go ahead and write that down, 45 degrees minus 30 degrees, and we just want to compute cosine of 45 degrees minus 30 degrees. That matches up nicely with our formula here, so we can just plug 45 degrees in for x and 30 degrees in for y. So that's cosine of x is 45 degrees, and then cosine of y is 30 degrees, and then plus sine of that first term, 45 degrees, sine of the second term, 30 degrees. And just computing, it's really the same thing as before, just with a plus inside of it. Cosine of 45 degrees, that's just root 2 over 2. Cosine of 30 degrees, that's just root 3 over 2. And then plus this time, and sine of 45 degrees, just root 2 over 2. Sine of 30 degrees, just 1/2. That's equal to root 6 over 4 plus root 2 over 4. So final result then is just root 6 plus root 2 over 4. And there we go, we have it. We are done. Okay, and before we go on, let's just take a look at these formulae again and see if there's an easy way to remember them. So just remember that they both start with cosine times cosine, and then they both end with sine times sine. So it's like cosine of the sum is cosine cosine minus sine sine, and cosine of the difference is cosine cosine plus sine sine. So it's really cosine cosine and sine sine, and then the operation between them is a little counterintuitive. You might think that cosine of x plus y should have a plus between the cosine cosine and the sine sine terms, but no, it's actually a minus. So just remember, the cosine changes the sign. The cosine is counterintuitive. Alright, now let's try to calculate cosine of 5 pi over 12. So unfortunately 5 pi over 12 is not a special angle, but let's see if we can express it in terms of some special angles. First of all, what are the special angles? Well, special angles are just pi over 6, pi over 4, and pi over 3. And just so it's easy to see how these might combine to make 5 pi over 12, why don't we express these all with denominators of 12. So pi over 6, multiply that on top and bottom by 2, so 2 pi over 12. And then pi over 4, multiply that on top and bottom by 3, so 3 pi over 12. Pi over 3, multiply top and bottom by 4, so 4 pi over 12. So are there any of these that can combine to make 5 pi over 12? 5 pi, well that's just 2 pi and 3 pi there. So we can add these together and that'll give us the 5 pi over 12. That is, we're just adding the 2 pi over 12 and the 3 pi over 12, or rather just the pi over 6 and the pi over 4. Okay, so putting all that together, let's write this out. So that's cosine of 5 pi over 12. We know that's equal to cosine of 2 pi over 12 plus 3 pi over 12. And then we can write that as cosine of pi over 6 plus pi over 4, just by simplifying those fractions. And now this is in a nice format where we can use the sum formula here. So let's bring it around here and apply the sum formula. So sum formula just says that we take cosine of the first term, cosine of pi over 6, then multiplied by cosine of the second term, cosine of pi over 4, and then minus sine of the first term, so sine of pi over 6, and then times sine of the second term, sine of pi over 4. Now it's just up to us to evaluate this. Cosine of pi over 6, that's just root 3 over 2, and then cosine of pi over 4, that's just root 2 over 2, and then minus sine of pi over 6, that's just 1/2, and then times sine of pi over 4, that's just root 2 over 2. Let's go ahead and multiply this out. Root 3 times root 2 is root 6. 2 times 2 is 4. And then minus 1 times root 2 is root 2. Again, 2 times 2 is 4. So just root 6 minus root 2 over 4. And there we go. That is our result. All right, here's a final example. We want to calculate cosine of pi over 3 minus x. And it's pretty clear here that we should use the difference formula, but we don't have it written down here. Let's try to remember it. So remember the difference formula. Both formulas actually go like cosine of the first term, pi over 3, times cosine of the second term, so cosine of x, and then there's also a sine term at the end. There's sine of pi over 3, and there's also sine of x. And then the way that the sum and difference formulas are different is that they have different operations between. So what's the operation that corresponds to negative inside the cosine? Well, remember cosine is counterintuitive, so it flips the sign. So it changes from a minus to a plus here. So this is what we need to evaluate. So let's go ahead and evaluate that. Cosine of pi over 3, that is just 1/2, and then cosine of x, and then we have plus sine of pi over 3, that's just root 3 over 2, and then times sine of x, and then we'll just write that once more nice and clean, 1/2 cosine of x plus root 3 over 2 sine of x. And there we go. That is an equivalent expression for this cosine expression. Now we know how to compute cosine not only for special angles, but also for angles which are sums and differences of the special angles. In the future, we'll also see how to do this for tangent.